In this lesson, we're going to talk about isosceles and equilateral triangles. Number one, isosceles triangle. Remember, isosceles triangles have two equal sides, and these sides are called leg. And the third side right here, this side is called base, right? So in isosceles triangle, number one, if AB is congruent to AC, then we can also say that these two angles, angle B is congruent to angle C. Okay? Or number two, if these two angles, angle B and C, are congruent, then we can say that these two sides are also congruent. Okay? Number two, equilateral triangle. Equilateral triangle is the triangle that has all three equal sides and all three equal angles. So each angle has to be 60, right? Okay, let's try example 2-1. Angle A is the vertex angle in an isosceles triangle, and angle B is 2x plus 6, and angle C is 5x minus 24. Then find the measure of each angle of triangle ABC. So here we have triangle ABC with the vertex angle A right here. Then the other two angles in this isosceles triangle has to be base angles. They are congruent to each other, right? So these two angles, angle B and angle C, they are equal to each other. So we can let 2x plus 6 is equal to 5x minus 24, right? So let's eliminate 5x on the right hand side, minus 5x, that's going to be minus 3x plus 6 is equal to minus 24, minus 6 each side gives us minus 3x is equal to minus 30. So divided by 3 gives us x is equal to 10, right? Well, actually divided by negative 3, right? Negative 3. So x is equal to 10. So if x is 10, here angle B is 2x, 2 times 10 plus 6. So that's going to be 26. So this is a 26 degrees, right? And C, angle C is congruent to angle B, so this must be also 26 degrees, right? So angle A, we know that sum of these three angles in a triangle must be equal to 180, right? So angle A must be equal to 180 minus angle B minus angle C, right? So 180 minus 26 minus 26, that's minus 52. So that's going to be equal to 128 degrees, right? Example 2-2. Given side AB is congruent to side AC in triangle ABC, the question is to prove that angle B is congruent to angle C. So here we have triangle ABC with the two congruent sides. AB is congruent to AC, right? And D is just the midpoint. Every segment has midpoint, right? So I have a midpoint here, and I drew dotted line from A to D, like that. Okay? And we're gonna write two column proofs. So always start with the given. AB is congruent side AC, right? AB is congruent to AC. That's given. And number two, D is just the midpoint. D is midpoint of BC. And reason, you can just say that every segment has a midpoint, All right. Number three, we can say that I drew dotted line from A to D, right? So I draw dotted line AD. Okay. So reason, you can just say the segment can be drawn through any 2 points. Segment can be drawn through any 2 points. Okay. So this is midpoint now. Then we know that side BD is congruent to side CD, right? So number 4, we can say that that's BD. Why am I keep saying AD? Okay, BD is congruent to side CD, right? That's definition of midpoint. Since this is midpoint, yeah, side BD is always congruent to side CD, right? Definition of midpoint. So far so good. And when we look at this triangle right here and this triangle right here, they are sharing this side AD, right? So we can say side AD is congruent to side AD, right? This was a reflexive property, remember? Reflexive property. So finally, number 6. So look at this. We mentioned that this side is congruent to this side, right? And this side is congruent to this side. And this side is congruent to this side. This was given, right? So all 3 corresponding sides are congruent, right? So we can say that triangle ABC is congruent to, that's ABD, right? ABD congruent to triangle ACD, right? Triangle ABD is congruent to triangle ACD. Does that make sense? Okay, this is side to side congruence. So finally, if 2 triangles are congruent, their corresponding angles and their corresponding sides are congruent, right? So we can conclude that angle B is congruent to angle C. Angle B right here is congruent to angle C. So I'm going to write angle B is congruent to angle C. And the reason is by CPCTC. Corresponding parts of congruent triangles are congruent, right?